In this video, I want to talk about special products of polynomials. These things are types of problems that come up quite often in algebra and upper levels of math, and they provide you a way to quickly solve a question with just a few simple steps. So there's essentially two types of problems that could be broken down into three. One is called the square of the binomial pattern and the sum and difference pattern. All right, so if we look at the square of the binomial pattern, what we see on the right here is an actual square. So this would be side length A plus B. All right, so this is side A plus B. The left side is side A plus B. So since they both have the same dimension, it's considered a square. So now what we can do is use that square or that table method of multiplication. So what would A times A be? That would give us an area of A squared. We would continue this A times B, which gives us AB, and then continue this for all the squares. Now, we can use this as a visual representation of what's occurring here. So if we have an A plus B side length in a square, and we square it mathematically, right? And if we use FOIL, we end up with this as our answer. A squared plus 2ABs plus B squared. These A and B's refer to numbers. All right, and so what we're going to see in the next slide is an example like this. So our A in this case is 1 and our B is 5. So our shortcut on the left tells us that we're going to take A, which is 1, and square it. So 1 squared is 1, and then we're going to keep a square on the x as well. So that gives us x squared. The 2 times AB is probably the most confusing of this. So what we do is we take the 1 times the 5, that's A times B, times 2. So it would be 2 times 1 times B, and that x is that 1x, which gives us 10x. And then we take the 5 and we square it, which gives us 25. So it's x squared plus 10x plus 25. Now, what happens if we have a subtraction sign? If we have a subtraction sign in here where it's A minus B, then the only thing that changes then is there's a subtraction or a negative sign for that 2AB term, right? So if we look at this example here, this provides us two different examples in one. So first, if we do the A squared, it's going to be 2 squared, which is 4, and then x squared, which is x squared. So you get 4x squared by squaring this first term. The 3 here, we're going to square it, and that becomes a 9. So it's negative 3 times negative 3, which gives us a positive 9. So in the middle, we have 2 times negative 3, which gives us a negative 6 times 2. All right, so negative 6 times 2 gives us a negative 12. So that's how we end up with a negative 12 here. So if we look at an example, we would square 3, and that would give us 9x squared. We would multiply 3 times 4. That would give us a 12x times 2 would give us 24x. And then we square, which would give us our 16. Okay, so 3x squared, that's the first part. And then 2 times 3 times 4 right here. And then 4 squared. That's the shortcut. And we can do that pretty much in our heads. As long as we know how to multiply these this can be a mental math shortcut. If we look over here, we have a difference now. So in this case, when we have that subtraction sign with a square up here, the middle term here, the 2AB term would become negative. All right, so if we square this, we get 25x squared. Right, and then we're going to do 5 times negative 2 is negative 10 times 2 is negative 20. And then we're going to square the end here, 2 squared and y squared. So we're going to end up with 25x squared minus 20xy plus 4y. Right. Okay. Now the next pattern we're going to see is called the sum and difference pattern. All right. Now what we notice here is there's the same number, the same A's and the same B's. The only difference is one B is positive and one B is negative. So it's the sum and the difference, but they're almost identical. There's just a plus and a minus sign. So if we were to FOIL this, what happens is the O and the I term would cancel out. And so we're left with just the F and the L. So the sum difference pattern is really just F and L, right? So in words, what this says is we take the first term, the A's, and we square it. We take the B's and we square it, and then we subtract them. Okay, so in this example here, we see the A is 1, so 1 squared is 1. X times X is X squared. And then 3 times 3 is 9, and then we subtract them. So it's square the first, square the last, and then subtract is how we do this particular problem. So let's take a look at this. So in this case, we're going to square t, that gives us t squared. 5 times 5 is 25, and then subtract them. And we end up with this. In this example B, we square the first, that would give us 9x squared. We square the second, which is y squared, and then we subtract them. So it'd be 9x squared minus y squared.